let's go through LeetCode 295, find median from data stream. For this question, it let us to implement a class median finder, which support two methods, add a number, which support add a number to this kind of data structure, and also find a median, which will return the median number from this data structure. It says that at most this many calls will be called, and also it says that there will be at least one element in the data structure before calling find median, so we don't need to check if it is empty, write some method to check it is empty or not. So for this question, what we're thinking about is that we use two heap. One is max heap, another is min heap. So let's say this is max heap, and this is the min heap. So if we add a number, what we do is that this process is that we add this number to the max heap first, and then we pull the largest number from the max heap to min heap. And after we do this process, we check the size because we add to max and also put into min. So it is possible that min heap has size greater than max heap. So we use we write if the min heap has size greater than max heap, we get the smallest number from the min heap and put that to max heap again. So that in this case, we are keeping the size of max heap will always greater equal to the min heap size. So because the min heap, those numbers are pulled from the max heap, so the numbers in the min heap will always greater equal to the numbers in the max heap. So the bigger part will in the min heap. So and also we doing like this way to check the size. If the max heap is smaller, then we have the max heap add a number from the min heap. So we know that max heap, the size is always greater equal to min heap. And also it will not because we add one to max and in the meanwhile put to min. So that means only when max is smaller than min, we add back min to max. So that means we'll only when this happens, we'll add one min to max. So that means the max size will never be greater than min size plus one, right? So it will be equal to min size or equals to min size plus one, will not be greater than min size plus one. So that means if in a data structure there are odd numbers, right? The max heap will have one more element. If they are even numbers, they will have the same size. So what we do is that if we check find the median, if it has odd number, for example, how can we check has odd number? We don't need to use another variable. We just check the size. If max heap size greater than min, then we just use pick to pick the number from the max heap, then return the median. If the size are same, we just pick one from the min heap and another from max heap and get a median, get the average. So let's write code for this. We need a two priority queue. we can just write a comparator reverse order. So when we let's talk about the process is that we have max heap offer this num and then min heap offer max heap dot pull. So what we do is that if max heap dot size is smaller than min heap dot size, then we have max heap offer min heap dot pull. So we know after we add the number, the max heap the size will greater equal to min heap, and if it is greater, will be min heap size plus one. So what we do is that if max heap dot size is greater than, right, or you can write equals min heap dot size plus one, min heap dot size. We just need to return. This is integer, so we need to come to the double, right? Max heap dot peak. Otherwise, what we need is a return 1.0 multiplied by max heap dot peak. Let's look at the range. You'll see the number will be 10 to the power 5, so we can just add, right? We don't need to worry whether it is out of range. Min heap dot peak. It is the integer. Otherwise, we need to convert to long and divide by 2. And Python code is very similar. Let's also write Python code. So we have we need to import the heap queue. We have, let's define self dot min heap equals this one, and self dot max heap equals this one, right? And what we do is that we firstly heap queue dot heap push, and we have self dot max heap push this number, right? And also we need to have a heap queue heap push. So we push to get one number from the max heap to the min heap self dot min heap, and we write because the min heap the things that we by default this is min heap. So for max heap in Python, what we write is actually how can we get a max heap is that we use a negative number to simulate those kind of max heap, right? So we put the line 10 as a minus number. And also, when we get this out, we will put a min heap because it's negative, right? So we should also get a negative to get the original number. Heap q dot heap pop self dot max heap, right? So we'll say if this kind of length self dot max heap is smaller than length self dot min heap. We need to add one back, right? So heap q dot heap push self dot max heap, and we get one number from the min heap that is also a negative, right? So we have heap q and heap heap pop. Um, from the min heap, which is a positive number, but we need to put it into max heap. We put a negative number into it. So we also use a minus self dot min heap. So this is the way we add a number. And for we find a number. So if length self dot max heap is greater than length of self dot min heap, so we just return those kind of from the max heap. That we put a negative number into max heap, so we'll return self dot max heap. This is peak, right? This is just get its index. Otherwise, we just return minus self dot max heap because we put a negative number into max heap, and plus self dot min heap 0 and divide by 2.0, right? So let's take a look. If this is a prince, heap max heap heap q heap q heap q heap q return max heap self heap IE and so doing like this, for the added number, the time complexity is log an operation, and the final median is that um is a O1 operation to get the heap top. So this operation is O1. This is O log K. K is how many data is in the heap already?